What's going on, guys? It's Greg here, and I want to talk to you about the importance of knowing what grid north means. Grid north is basically the north that's printed on your map. So if you're navigating with a map, you're going to want to know what the grid north is. If it doesn't say grid north, then what you're going to want to do is just look for an N, and that's your north. So when you orient your map, you want to orient your compass to the north line here. All right, and that's what they call the grid north. And you're going to orient your compass. You're going to orient your map to this. You're going to twist the map. I'll show you in a few minutes how to do that. So this way your compass is aligned with the map and they're working in sync, because you don't want to be off because of magnetic north. I talked about that in a different video. I talked about magnetic declination. That's the difference between magnetic north and true north. You can be off quite a bit if you're not orienting the map. If you're not orienting the grid north of the map to your compass needle, you're going to be off based on what the magnetic declination is, which is 13 degrees here. So basically what you need to understand, which I talked about in a different video, I'm going to put the link. I'm gonna put a link in the description box, and I'm gonna attach it to this video so you can watch that one. But basically you have three types of north. You have magnetic north, which is what your compass needle works on. You have true north, which is north, the actual true north, the North Pole. And then you have grid north, which is what's the north on the map. So if there's no grid north, which is typically abbreviated GN, then that means that if it says N on the map, then that's going to be your grid north. And true north is TN, and then magnetic north is MN. So those are your abbreviations: MN, TN, GN. And it's critical that you have to know what your map is oriented to. It has to be, you have to orient your map to your compass to your north line here. Otherwise you're going to be off quite a bit. So like in my part of the country, the magnetic declination is 13 degrees. So if I didn't orient my map to my compass and I just laid my compass down on the map and I just started following, whatever azimuth I was making on the map, I'm going to be off by 13 degrees, so that's quite a bit. If you're covering like a couple of miles, that's going to, you could end up getting lost. Basically what that would mean is, let's say like, I wanted to go from this ridge here, Cradle Rock Ridge, to, let's say up here, Millbrook Ridge. If I wanted to, let's say, walk across this valley here, there's a little stream here and it's a valley. If I wanted to cross it, if I just laid my compass down without turning the map towards the grid north and aligning it with my compass needle, then I'm going to be off by 13 degrees. So what's going to happen is, as I'm traveling here, I'm really not going to be traveling what I marked. Like let's say if I'm going from this peak, I don't know if you guys can see here. I'm going to see if I could show you better. So let's say I'm going from this peak right here. This is a peak. This is 3,100 foot peak. Let's say I want to go to this peak right here, this little circle in between Brook Ridge right here. That's 3,200 feet. If I wanted to go from this peak to that peak, that's going to be about 2 miles, let's say. If I just mark it on the map and I follow this with my compass, if I just lay my compass down, if I lay my compass down here between these two and I take a reading, azimuth, and then I follow that azimuth, even though I'm lined up on the map, I'm going to be off in reality by 13 degrees, because I'm going to be following magnetic north and not the grid north that the map is set up for, So that could be quite a bit. I could be, instead of, let's say, coming up over here on the peak like I want to, I may end up over here somewhere in one of these saddles. I may end up in one of these saddles here, or in one of these calls, like over here somewhere. Rather than being over here, I'm going to be off, and then I could get lost, So it's very important that you understand, when you're using a compass with your map, that you have to align, you have to orient the map to your compass needle so you're not off by the magnetic declination. And I did a separate video on that. But basically, if you can't orient if you don't want to orient it, what you could do is you can add the number. See, like this number here, 13 degrees. If magnetic north is to the left, that means you add it. There's an acronym, it's called LARS, left add, right subtract. So let's say I took a reading here from here to there, and let's say whatever it was, well, let's say 100 degrees from here to there, 100 degrees. If I don't want to orient the map, let's say if I don't have a flat surface to lay this down and twist it so it's aligned with the map, what I can do is I can just add this number to the 100 degrees, and it'll be 113, and that'll be my correct reading, which will correspond with the map north, the grid north. So that's just a little tip, if you don't have a place to orient your map, just add this number. If the magnetic north is to the left, and if your scale shows the magnetic north to the right, then you subtract it. So just remember the importance of grid north. It's critical. You got to make sure that you're using the scale that your map is set up for. And basically, when you're aligning the map, I'll try to show you quickly. When you're orienting your map when you're orienting your map to your north, what you want to do is, I'll show you. You want to twist the map. So like right now, north is this way. So what you want to do is you want to put the map on a level surface that doesn't have any metal, because if you have any kind of metal, it's going to throw your compass off. And what you want to do is you want to line up the north line here with this, so they're the same, so they're both aligned. Like right now they're pretty much aligned. Right now the map is aligned to my compass. I'll show you. See, hold on. So if this was a flat surface right now, as you can see, the compass needle is roughly about the same as, let me see if I could get a better picture for you. Hold on. Let's see here. I'm going to use the back of this board, or actually just use this. Alright, so if this is my non-conducting flat surface, what I'm going to do is I'm going to lay it down. First I'm going to lay my compass down, and I'm going to find out where north is. What's going on? I guess there must be metal in this one. That's kind of a problem. Let's see, is there any other way? Well, I'll try to do it by hand just so I can show you on hand. So basically just, you're going to want to line up your compass needle. Let's see here. You're going to want to line up the north line with the compass needle, You see how the north is lined up with the compass needle? So now my map is aligned with my compass, and now I can take readings with my compass. If I was to just put this flat on a nice, non-conducting surface just like this, then I can start taking bearings with my compass, and it's going to be accurate. It's going to be accurate to the grid north. So just keep that in mind, guys. I hope this video helped you out, and thanks for watching.